Here is the last question on our search for ambiguous cases, question 5. It is a thinking and communication question. Question 5. Given a triangle ABC with angle A equals to 60 degrees and B equals to 2 centimeter, determine the range of values for the side A opposite to angle A that will ensure two possible triangles as a part of solution. Explain your thinking. Well, that's kind of summarizing the whole ambiguous search itself. And try to get this and explain it in the most beautiful way you can. Okay. What I'll do is I'll just draw a triangle which will be a right angle triangle. Right angle triangle where this is my angle A, which is given as 60 degrees, right? 60 degrees. And that's my side B and this is my side C. Opposite to side B, I'm taking 2 centimeters. So this is 2 centimeters, correct? This is my side B equals 2 centimeter. And side A is not known to us, correct? That is what we have to figure out. How much should that be, right? Let's read the question once again. Given a triangle ABC with angle A equals to 60 degrees and B equals to 2 centimeters, determine the range of values for the side A, which is opposite to angle A, that will ensure two possible triangles as a part of solution, and explain your thinking. Well, the example which I have taken here, it shows like a right angle triangle here, and this is the one which will give me only one solution. Do you understand? Only one solution, right? Now if I need two solutions, then this side A should be greater than CB, right? If it is greater than CB, then I get two solutions. Do you see that? But if my side A is less than CB, then I don't get any solution. Do you understand? So that is the philosophy which we are going to use to figure out all the possible values A can take so that we get two solutions, not just one. Okay. So first thing is, let's find out what value of A will give us just one solution. So let's find out one solution. So one solution is possible if we have right angle here, correct? Then that means it is just one, right? It will touch only at one point. So if this is right angle, then what should be A? So A over B is sine of 60 degrees. So sine 60 degrees is equals to A over B, and we know B is 2, right? So we know B is 2, and therefore A is equals to 2 times sine of 60 degrees, correct? So let's do sine of 60 degrees, which is equals to square root 3 over 2 times 2. Times 2 will give me square root 3. So that gives me, that is equals to, let's say, square root of 3, right? Well, some calculators will give us a decimal value, and that decimal value is 1.732. So which is kind of equal to 1.732, right? So we can use any of these values possible, right? A is equals to square root of 3. At that time, we get a right angle, correct? So it should be more than square root of 3, right? A should be more than square root of 3 to give me two solutions. But what is the maximum limit of A? It cannot be more than the hypotenuse 2. The ambiguous case is that A should be less than 2 centimeter but greater than square root of 3, right? So now, from here we can infer that the value of A should be greater than square root of 3, so that we get at two triangles, correct? Like this. Do you see any two triangles? More it is, right? But imagine, if A is equals to 2, then what? More than 2, then what? Do you see that? Then it will be like a different, you can't make this 60 degrees. Do you see that? It goes outside, right? So therefore the limit for A is that A should be greater than square root of 3 but less than 2 centimeters, correct? 2 centimeters. These units are in centimeters, correct? So that is our solution. That is how we can find range of A values, and we can find And we can write this range as range for A. I should have written A here. Let's say Y normally we write. Is that A belongs to real numbers. So that A is greater than square root of 3. That's the exact value, and therefore I'm taking square root of 3. You could write approximately 1.732, but less than 2, right? These units are in centimeters, right? Where this is in centimeters and this is also in centimeters in our case, correct? So that is our answer. I hope you understand. Thank you.